Is scarab Jew frequently misspoke as insect Jew? Is a red monster star very unsound and going to detonate in the huge scope of the universe? There exists a star not at all like some other, a monster of the universe known as Betelgeuse. Behind its superb appearance lies a ticking delayed bomb prepared to release an immense exhibition that will shake the very groundworks of how we might interpret the world. How would you think humankind ought to plan for such an enormous sublime occasion? And how exactly would Scarab Juice's blast reshape our comprehension of the universe? Go along with us as we unwind this secret in the immense region of space where stars are conceived, live, and at last, disappear. There is one star that has been causing all a mix among stargazers and the general population insect Jew. This huge red very Goliath, found unmistakably in the group of stars of Orion, has consistently stirred our interest with its sharp red sparkle and propensity to shift in brilliance. In any case, recently, there have been some intriguing improvements that have elevated our interest in this radiant Goliath. Betelgeuse is an absolute monster, roughly multiple times bigger than our sun. Envision a star so immense that if it assumed the sun's position, its surface would stretch past the circle of Mars, gobbling up Mercury, Venus, Earth, and Mars through and through. Its enormous size isn't simply an irregular reality. It's a sign to where it remains in its life cycle. As a red very Goliath, insect Jew is in its declining years, extending and cooling down after a long period of consuming hydrogen into helium in its center. Bug juice, at around 8 to 8.5 million years old, could sound youthful contrasted with human norms. However, in the realm of stars, it's old. It has seen more than its fair portion of astronomical show throughout the long term, brought into the world from the red-hot cauldron of a heavenly nursery. It emerged as a hot, glowing blue star, radiating extreme energy. After some time, the star went through a significant change, developing into the gigantic red very monster we wonder about today. This change is a demonstration of the persistent transaction of two grandiose powers: atomic combination and gravity. Inside the bubbling center of scarab juice, hydrogen particles intertwine into helium, delivering stunning measures of energy that power the star's splendor. Yet, as the star debilitates its atomic fuel, gravity applies its relentless draw, making its external layers extend outward in planetary extents. Dissimilar to the sun, whose surface bursts with a searing yellow-white splendor, scarab juice's cooler temperatures pervade it with a rich rosy tone, emanating warmth and secret into the universe. Betelgeuse's story isn't simply one of static splendor. It is a story of progress set apart in the record of mankind's set of experiences. Old texts from societies around the world discuss scarab juice's moving colors, with records of the star seeming yellow in ancient times before changing to its ongoing crimson appearance. This shift offers a window into its infinite process, an excursion that goes on before our eyes. In the midst of bug juice's eminent excellence lies a puzzling fluctuation in splendor that has confused cosmologists for a really long time. As a semi-normal variable star, its brilliance level withdraws and streams in a hypnotizing heavenly dance, a rhythmic cycle painstakingly sought since the 19th century by cosmologists like Sir John Herschel. They disclosed a grandiose movement that resounds through time. However, scarab juice's grandiose dance isn't simply a story of consistency, but an adventure of great anomaly interspersed by unanticipated turns. In late 2019, scarab juice revealed its perfect darkening, projecting a cloak of secret over the night sky. This red very Goliath, a heavenly signal in the Orion heavenly body, left on an excursion of infinite change, shedding its splendid shroud. As time passes, the star's splendor decreased at an exceptional rate, becoming more obscure by 0.1 extents each day until it arrived at its most reduced splendor in February 2020. This emotional occasion, noticeable even to amateur stargazers, started a furor of hypothesis among researchers worldwide. While Betelgeuse's fluctuating brilliance is entirely expected, the size and length of this obscuring occasion left researchers grappling for replies. Was bug juice near the very edge of a deplorable cosmic explosion blast? Or was this only a brief infinite anomaly bridging the tremendous field of room at the speed of light? Its splendid light sets out on an inestimable venture, spreading over roughly 725 light-years prior to arriving at our eyes. In the midst of the enormous strain of insect juices fluctuations lies a progression of unanswered questions, inviting cosmologists and skywatchers the same to consider the mysteries of the universe in a mission to unwind the confounding behaviors of Betelgeuse. Andrea Dupre, the regarded partner overseer of the Middle for Astronomy at Harvard and Smithsonian, left on a grandiose excursion with her group. Outfitted with the unrivaled capacities of the Hubble Space Telescope, they left on a 3-year attempt to inspect the external compasses of the heavenly monster. Their perceptions offered an enticing look into the dynamic interchange of its enormous dance. Taking advantage of Hubble's aversion to bright light, the scientists dug into the star's air complexities, unveiling a hypnotizing assortment of troubled convection cells. Analyzing a series of spectra caught throughout 2019 and 2020, Dupre and her group revealed the many-sided dance of material inside Betelgeuse's divine domain. Zeroing in on magnesium Roman II lines, they decoded the barometrical congruity, revealing material rushing at very fast velocities of 200,000 miles per hour from the star's surface into its external ranges. This infinite removal of hot dense material reached out across a large number of miles, signaling the introduction of a great dust cloud that encompassed Betelgeuse in its astronomical hug. Dupre's estimations revealed that a remarkable flood of material, 2 times the norm, radiated from Betelgeuse's southern hemisphere over 3 groundbreaking months. As the residue gotten comfortable, Betelgeuse risen up out of its enormous shroud. Stargazers wondered about the heavenly scene, lowered by the complex dance of heavenly powers that administer our huge and wondrous universe. The huge mass misfortune from Betelgeuse, while normal for stars, was particularly important given its size, far incredible the pace of mass misfortune seen in our Sun. This abrupt shedding of material, combined with an ensuing obscuring of its splendor, touched off conversation among cosmologists worldwide, powering hypothesis about the star's destiny. Stargazers considered whether this dim occasion could envoy the long-anticipated scene of a cosmic explosion blast, an occasion of unmatched size that would offer mankind a fantastic view to notice the birth and end of a heavenly monster. Yet in the midst of the hypothesis and energy, one inquiry lingered. What does this obscuring forel for Betelgeuse's future? Is it an indication of an inescapable blast, or simply a short-term abnormality in the star's renowned excursion? Different hypotheses arisen to make sense of the cryptic obscuring. Some trust the obscuring to be a result of interstellar dust clouds passing in front of Betelgeuse, temporarily dimming its light. Others speculate that it could be a consequence of complex convection processes within the star itself, leading to fluctuations in brightness. Regardless of the cause, the dimming of Betelgeuse has captured the attention of scientists and stargazers alike, prompting a flurry of observations and analyses to better understand this enigmatic phenomenon. With each new discovery, our understanding of stellar evolution and the behavior of massive stars like Betelgeuse deepens, opening new avenues of exploration and inquiry. As we peer into the depths of space and unravel the mysteries of celestial objects like Betelgeuse, we are reminded of the vastness and complexity of the universe. Each observation, each discovery, brings us closer to unlocking the secrets of the cosmos and expanding our comprehension of the forces that shape the cosmos. In the face of such cosmic uncertainty, humanity's role as curious observers and explorers of the universe is more important than ever. By continuing to study and learn from phenomena like the dimming of Betelgeuse, we not only gain insights into the workings of the universe, but also reaffirm our place within it as stewards of knowledge and discovery. So, as Betelgeuse continues its celestial dance, fluctuating in brightness and captivating our imaginations, let us remain vigilant in our pursuit of knowledge, ever eager to uncover the mysteries that lie beyond the reaches of our earthly domain. For in the vast expanse of space, there are still countless wonders waiting to be discovered, and it is our insatiable curiosity that will guide us on this cosmic journey of exploration and understanding. Flagged a significant stage in the blast process, energized by the winning conviction that scarab juice is approaching the finish of its life. Others proposed that a thick residue cloud may be beginning from the star's material darkened its splendor from our natural view. A third hypothesis proposed changes inside its photosphere, the noticeable external layer of the star, guessing that modifications in its structure could influence its brilliance. To unwind the star's secrets, space experts went to different observational methods, including spectroscopic investigations that uncovered a stamped decline in Betelgeuse's powerful temperature. These examinations disclosed an entrancing disclosure. The obscuring matched with a significant decrease in temperature, alluding to the presence of a monstrous dim spot on its surface. With every disclosure, the riddle of Betelgeuse's obscuring occasion started to disentangle, offering enticing experiences into the intricate operations of grandiose peculiarities. At last, the secret surrounding this remarkable occasion was decoded with the significant guide of the Hubble Space Telescope. Humankind's careful attention on the universe through its fearless look, Hubble uncovered the reasonable justification behind insect juice's obscuring, a huge removal of intensely hot material into the huge scope of room. This launched-out material joined to shape a thick residue cloud, darkening a section of the star's surface and subsequently reducing how much light contacting us. This residue cloud was accepted to have started from superheated plasma ejecting from a gigantic convection cell on the star's surface and afterward moving through its singing climate toward the external cooler layers. As this plasma cooled and consolidated, it shaped minuscule residue particles that unified to make a shroud, darkening light from roughly a quarter of Betelgeuse's broad surface. Hubble's bright light spectroscopic perceptions, which started in January 2019, assumed a critical part in recreating the sequence of occasions paving the way to Betelgeuse's obscuring. These perceptions caught obvious indications of thick warmed material flowing through the star's air layers in the months going before the obscuring. In December 2019, a progression of ground-based telescopes additionally recorded the star's continuous melting away in brilliance, especially obvious in its southern half of the globe. This material at first delivering more brilliance than its standard brilliance, ultimately blended into a dull-hued cloud as it spread outward and cooled. The winning speculation suggested that this outflowing material and the ensuing development of the residue cloud were answerable for Betelgeuse's unexpected obscuring. The magnitude of this launch was truly stunning, moving insect juice into the spotlight and charming the world's imagination. The star released an estimated 400 billion times the mass normally released in a standard gigantic mass discharge, comparable to several times the weight of our moon. This momentous occasion wasn't only huge for insect Jew alone. It additionally offered significant bits of knowledge into our appreciation of heavenly mechanics. Yet, what does such a gigantic ejection of material connote for creepy-crawly juice and the more extensive hypotheses encompassing heavenly development? The repercussions are significant. Customary speculations recommend that red supermonsters like bug squeeze consistently shed mass before their hazardous end. However, the sheer size of this discharge challenges this idea, alluding to more fierce and maybe erratic last stages for these stars. Later studies consider the timing of such an occasion, suggesting that it could happen sooner than previously expected, perhaps within years and years. As this immense star travels through space at around 67,000 miles per hour, comparable to its surrounding planetary cloud, it produces a bow shock like the wave formed by the bow of a moving boat. This exceptional peculiarity arises as the star's external layers communicate with gases and residue, offering a stunning display that highlights the star's dynamic nature and its incredible dance with the vast background. Contemplating Betelgeuse's bow shock not just provides insights into its current condition, but also enhances our understanding of how stars evolve and lose mass over time. This shock peculiarity occurs as the star's external layers interact with the interstellar gases and residue, creating a marvelous confirmation of the star's dynamic nature and its association with the enormous climate. However, Betelgeuse's late way of behaving has caused a commotion among space experts. Observations have revealed that its surface has cooled and become less dense since the emission occasion, leaving the star in a shaky state even years later. Hydrodynamic recreations recommend a connection between the star's convective activities, the mass discharge, and subsequent changes in throb mode. This ongoing dependability prompts inquiries concerning the inside mechanisms driving these changes and their potential future results. Also, Betelgeuse's noticed pace of mass misfortune is substantially higher than that of numerous different stars, suggesting a complex exchange of inward forces. The stream driving this mass misfortune is somewhat indicated by the ceaseless scattering of energy through shock warming and mass discharge. Such observations highlight the dynamic and to some degree erratic nature of Betelgeuse's life cycle, prompting cosmologists to reconsider their models of heavenly development. In the midst of these dramatic changes, one may keep thinking about whether Betelgeuse is on the edge of a cosmic explosion emission. The chance of Betelgeuse going cosmic explosion has captivated cosmologists for a really long time, yet the exact timing of such an occasion remains dubious. Ongoing examinations hypothesize about the timing of such an occasion, suggesting that it very well may be sooner than previously suspected, possibly in just a few huge number of years. While the exact timing of such an occasion remains dubious, the new remarkable mass discharge has clearly shifted the conversation, suggesting a more inevitable end than previously thought. Speculations presently struggle with the repercussions of this gigantic loss of material and what it implies for the star's stability and future. As the cosmic local area centers its attention on Betelgeuse, another vast occasion gets our advantage and offers a compelling correlation: the cosmic explosion SN 2023X. This amazing blast took place in the universe more chaotic 101, gently known as the Pinwheel System, found only 21 million light-years away. Discovered in May 2023, SN 2023X isn't your normal cosmic explosion. It's the nearest one saw in later memory, giving an extremely valuable impression into a star's emotional great finale. The discovery of SN 2023X was nothing short of an inestimable victory. Kayagaki, a celebrated beginner cosmologist known for his ability for finding supernovae, first detected this quickly lighting up right on the money the edges of more chaotic 101, utilizing a humble 35mm telescope. Once he declared his revelation, the cosmic local area jumped right into it. Telescopes all over the planet, from those positioned on Earth's surface to the circling Hubble Space Telescope, quickly pivoted to catch the unfurling scene of this new infant cosmic explosion. The hurry to follow its brilliance curve gave critical bits of knowledge into the blast's nature and the climate encompassing the doomstar. In the violent months following its revelation, SN 2023X's way of behaving was painstakingly recorded. The cosmic explosion quickly progressed from relative lack of clarity to astonishing pinnacle splendor in only 5 days before bit-by-bit blurring, losing Z3 extents of splendor day to day. Definite investigation of SN 2023X's range uncovered splendid emanation lines, showing savage associations between the cosmic explosion shock wave and encompassing gas. This cosmic explosion was a center breakdown occasion, with the star shedding up to a sunlight-based mass of material in its conclusive years. Grasping SN 2023X makes a difference. Refine models of heavenly